Okay, so this is 7.4, which is writing and graphing exponential growth functions. 7.5 will be about writing and graphing exponential decay functions. So let's first determine what exponential means. We've talked about exponents earlier as being, in the exponent, if we want to write x to the third power, the 3 is the exponent. So what we want to think about is exponential growth. To introduce this is talking about growing exponentially is a little bit different than what we've done in the past, which is growing linearly. So let's first define what an exponential growth model is. So an exponential growth model, and it doesn't really fit here, but that's okay. Exponential growth model is a function of the form y equals a times b to the x power, where a is not equal to 0, a cannot be equal to 0 because the whole thing would be equal to 0, and b is greater than 0, and b is not equal to 1. Okay, so there are a couple of stipulations there. Exponential functions are nonlinear functions. Okay, so we're going to talk about the difference between a linear function and an exponential function. So here, when you look at a linear function, one thing that has been talked about is as your x changes, your y changes consistently. So notice, when we go from -2 to -1, our y is changing by 3. When we go from -1 to 0, it's still changing by 3. From 0 to 1, it's still changing by 3. So as we go from -4 to -1, and 1 to 2, and 2 to 5, and 5 to 8, because these are all changing by the same amount, these are all changing by the same amount. With an exponential function, it is also true that it's going to change by the same amount, but in a different manner. So here, we're just adding 3 each time. Okay, so we're adding 3 every single time, whereas here, as we increase by 1, we are going to be multiplying by a specific number. And the number that we're going to multiply by is always determined by this value right here. Whatever you have raised to the exponent, okay, wherever the exponent is, the base of that. So again, if I write this 3 to the x power, again, this right here is the base. Okay, and then this right here is the exponent. So therefore, whatever your base is, that is what you are multiplying by on your y value. And think about this. If we were to go back and talk about when we have 2 to the third power, that was equal to 2 times 2 times 2. So each time we are multiplying by the base. So that it's just a multiple of 2 each time. So down here it's the same thing. Notice what happens. If I multiply 2/9 by 3, I get 2/3. If I multiply 2/3 by 3, I get 2. If I multiply 2 by 3, I get 6. If I multiply 6 by 3, I get 18. That's an exponential model. Now, this number right here, this number will always be your starting point. That's always where you start. So if x is equal to 0, this is what your y value will be, because 3 to the 0 power is equal to 1. 1 times 2 is 2. That's why this right here shows what our starting point is. When x is 0, our y is equal to 2, because this right here is 2. Okay? 3 comes from what we have to multiply each one by to get to the next number. So the easy ones to look at are your whole numbers. 2 times what equals 6? 3. 3 times what equals 18? 3. And as long as it's the same number all the way through, then it is an exponential model. So let's look at this example. We're going to run through this pretty quickly. So we know that our exponential model has to be y equals a times b to the x. So we just talked about how we know what our a is going to be. Our a is going to be based on what our y value is when x equals 0. So we look at this value right here. So a is going to equal 8. Then for b, our b value is determined by what do we multiply each one of these by to get to the next number. 2 times what equals 4, 4 times what equals 8, and it should be the same number. 2 times 2 equals 4. 4 times 2 equals 8. So therefore, b is equal to 2, and our rule, or our equation, that's what rule means. Rule just means write an equation. So we have y equals 8 times 2 to the x power. Okay? what I want you guys to do is do this one on your own. You need to pause the video, try this on your own. It should only take you a minute or two, and then hit play when you're ready. Okay, so for this equation, you should have gotten y equals 27 times 3 to the x. Again, 27 is our a because that's where we're starting. That's what our value is when x equals 0. So that's our a. And our b is 3 because each time we are multiplying by 3 to get our value. Okay, so let's move on. So for this one, what we're going to do is we're going to talk about graphing. So graphing is actually not that much more difficult. It's kind of going in the opposite direction of what we just did. But what our steps are going to be is we always begin or start by choosing x values of x. Values of x, I'm sorry. Then we're going to plot the points or graph the points. And then we're going to connect the points with a smooth curve. So what we're going to do here then is I typically use the same values over and over again. It's always -2, -1, 0, 1, and 2. But understand, you can pick whatever values you want. I just think these are a good set of values to use. And then all we're going to do is plug these values in. If you want to use the calculator, that is completely fine. I have no issue with that. So we're going to have 3 to the -2, but we should also know that 3 to the -2 is the same thing as 1 over 3 to the 2. That comes from section 3, which is 1 over 9. So that'll be 1/9. And then 3 to the -1 equals 1 over 3 to the first, which is just 1/3. I'd rather you not use decimals here, so it's good to be able to do it this way. And then we plug in 0. 3 to the 0 is equal to 1. 3 to the 1 power is equal to 3. And 3 to the 2 power is equal to 9. And then all we need to do from there is start plotting our points. -2, comma 1/9. So somewhere right around here. -1, comma 1/3. So a little bit higher than that. 0, comma 1. 1, comma 3. And 2, comma 9. And you get the idea that our graph should look something let me scroll up here. Our graph should look something like this. And you should be able to do this by hand. You should not have to use the graphing calculator to do this. Okay? Then the last part is identifying the domain and range. So domain, we have to recall, domain is possible x values. Like what possible x values can we get? Okay? In other words, what can we plug in for x? And if it's anything, which in this case it is, our domain is all real numbers. So if we can plug anything in other words, if there's no limit to what we can plug in, then our domain will be all real numbers. For the range, our range is going to be possible y values. Now this is a little bit different because we don't just plug in y values. Our range will always be determined by what our domain is. So when we plug in all of our x values, what you should notice by this graph is that our graph never goes negative. So the range, if we're going to say our possible y values, we can't say that it can be anything because it never goes negative. We want to look at our graph and see what is on the graph. And here it's just y is greater than 0 because anything above 0 is going to be in our range. That's the y values that are represented by this graph. That's what we want to write for our range, is what y values are represented by the function that we have. For all exponential functions that are increasing like this, that look like this, that it will always be y is greater than 0. It never goes negative. There are some functions that can change that, but for the most part, it will be either y is greater than 0 or y is less than 0. Okay, so again, you have one to do on your own below. So what I want you to do is try that one and then hit play when you're ready. Again, there's a middle part here for you to show your work. In other words, just plug your value in. So I will start this out for you. Use these x values, -2, -1, 0, 1, and 2. And then I just want you to plug these values in and then do the best you can. I know you might not have a calculator. Just do the best you can to get that value Again, I'll do the first one for you. This is saying 1/3 times 2 to the negative 2. 2 to the negative 2 is, this will be 1/3 times 1 over 2 squared. Remember, the negative 2 just brings it to the bottom. So it's 1/3 times 1/4, which is equal to 1/12. So 1 over 12. So try and do that for the rest of them and then hit play when you're ready. All right, so when you plotted these points in, you should have gotten 1/12 for your y, 1/6, 1/3, 2/3, 4/3. And again, a good way to do this is once you understand what you're starting with, you can just multiply by 2 going to the right and divide by 2 going to the left to get all of your values, because that 2 means that you're multiplying by 2 each time you increase by 1. Okay? So hopefully that graph makes sense. Plotting the points, notice no matter what, the graph still looks similar for an exponential growth. They may not grow as fast, but they still look exactly the same, or pretty much the same. Okay, the last part is, right here we have this paragraph that says when a is greater than 0 and b is greater than 1, the function ab to the x power represents exponential growth. When a quantity grows exponentially, it increases by the same percent over equal time periods. To find the amount to which the quantity grows after t time periods, use the following models. So here's what we have here. This is a function that will help us. It's a growth model. So a right here is going to be your initial amount. So we're going to talk a lot about money with these models, where you can see how money will grow. So a would be the initial amount. R is going to be the growth rate. Usually that's given as a percentage, and we will change that percentage to a decimal. And t is going to be the number of years. Okay? We consider the entire 1 plus r, that is considered the growth factor. You usually won't be given the growth factor, but it's good to know what that is. So let's look at this example. It says you put $125 in a savings account that earns 2% interest, compounded yearly. If you do not make any deposits or withdrawals, how much will your investment be worth in 5 years? So we're given 3 things: $125, 2%, and 5 years. So you've just got to figure out which of these variables do each of these go in. Well, 125 is our initial amount. So we're going to have y equals 125 times 1 plus, r is our growth rate as a decimal. So we want 2% to be a decimal. Please remember that it's moving the decimal 2 places. It should be 0.02, not 0.2. And then t is the number of years, which in this case is 5. So you literally would just put that right into the calculator as you see it, and you would get $138.01. And again, the calculator will give you that as long as you plug it in correctly. So after 5 years, our $125 would be worth $138. And that's what you get with very small interest. Okay, so that's all we have from section 4. Don't forget to take your Edmodo quiz. Make sure you bring questions tomorrow if you have any. I hope that this was pretty straightforward. So I will see you later.